Hi class, welcome for today's lesson. Today's learning outcome is to state Newton's law of motion and to use the formula for the motion. And this is class by Raj teaching for Physics Semester 1 STPM. In classical mechanics, Newton's law of motion are three laws that describe the relationship between the motion of an object and the force. The first law says that an object that is at rest will remain at rest, and if the object is moving, it will continue to move with a constant velocity unless acted upon by an external force. An external force is a force that acts outside of a system. In simple words, we can say that an object cannot start, cannot stop, or cannot change direction of their own. They require some external force to cause them such a change like stop, start, or change direction. This tendency of object to resist certain changes of their motion is known as inertia. Second law. The second law states that the rate of change of momentum is directly proportional to the resultant force. That means F is directly proportional to the rate of change of momentum and is in the same direction as the resultant force. The third law says that every action has a reaction, same magnitude but opposite in direction. Now let's look at the example of application of Newton's law. It is very important to learn how to apply Newton's law in solving questions. When we have a pulleys system like this class, let's analyze in how to solve pulleys system. Basic concept of how to solve pulleys system. Now, when you see this kind of pulleys system, the first thing is to draw the forces. Draw the force. Okay, so now what we do first is for this object, the direction, the first force that acts on it is weight, which is mg. And then we have also, because it's a string here, so we have a tension in the string. Okay, and then here we have a mass here, which is the weight, which is capital mg. And then we also have a tension here because it's a string, so the force that acts on the string will be a tension. Okay, so now we already draw the forces. Okay, now second step is to look, in order to apply the Newton concept, we have to either look at it in three ways. Okay, the first way is either we look at it individually. Number one, just look at this particular mass, or we can look at this individually. Number two, or we can look at the whole entire system, which is number 3. Okay, so let's look at number 1. Okay, I have a mass. Okay, we solve this particular thing here, m, and then I draw the forces for this particular object, which is T, and then the force here, which is mg. Okay, so in order to apply Newton's second law, where the acceleration of this mass is in this direction, in order to apply Newton's second law, we have to find the resultant force. So what will be the resultant force, class? The resultant force will be mg minus t, because the acceleration, the motion is downward. So therefore mg minus t. Okay, And according to Newton's second law, resultant force is equal to ma. So mg minus t is ma. Okay, so if I want to find the acceleration is equals to mg minus t divided by m. The m here is the mass that is involved here. Okay, that is number 1. Now number 2. Okay, let's look at this. So if I draw the figure for number 2, okay, so the forces that acts on number 2 is, first is the weight, which is capital mg, and the next one is t. Okay, so this is no friction, smooth plane here, smooth table or plane here, so there's no friction. Okay, so therefore we have this. So what we should do now, the first step is to find the resultant force. Okay, what will be the resultant force? You see, the motion of this object here is in this direction. So we only consider the force that is involved in that motion of that direction. So which will be, the resultant force will be T. Okay, according to Newton's second law, it is equals to ma. So T is equals to m is the mass, which is capital Ma. So A is equals to T over M. Okay. Now, when we look at the whole entire system, which is number 3. Alright, which is number 3. Okay, when we look at the whole entire system class, now let's look at this. This is the motion for this object at this position. This is the motion of this object at this position. So what you should do is you make it into a straight line. So when you make it into a straight line, you will have something like this. Then you draw the forces. Okay, here will be mg, here will be T, and here will be T. Okay, even though you have this capital mg, which will be in this direction, but we don't consider it because our motion is horizontal like this. So this is not influenced by this force. Okay, then we find the resultant force, which is mg. Why mg? Because T and T cancel each other. Okay, so mg is equals to, Newton's second law say ma. So here the mass will be the total mass of the system, which is capital M plus with small m times with A. So A is equals to m plus small m divided by, sorry, okay, A pula, okay, wait, capital A is equals to mg divided by capital M plus small m. Okay, you bring it this side. Okay, alright, so this is how it is done. Okay, so by looking at tree system. Okay, when you look at this system here, this is an inclined plane. Okay, now what is the first thing you should do, class? That's the first thing you should do is you draw the forces. Okay, you draw the forces. So when you draw the forces, what you have is that this is angle theta. Okay, so if I draw the forces, I'm going to draw with the black pen here. The weight will be mg. Okay, alright, then we resolve step number 2. We draw the forces first. Of course, there will be a normal force here, which is N. Okay, then we resolve this force. Okay, second step is to resolve the forces. Alright, so which force need to be resolved? This force. So when you resolve it, you get it like this. So this becomes theta. So here becomes mg cos theta. Here become mg sin theta. Okay, alright. Then in case if in this inclined plane there is a friction, okay, assuming there is a friction, okay, so if the object is going in this position, so the friction will act in this direction. If I put a small f, the friction will act in this direction. Okay, alright. So how to solve this? The motion is in this position, correct? The motion is in this horizontal motion. So you find the resultant force, okay? You find the resultant force. Which is in this case is mg sin theta minus F, which is the friction, equals to, according to the Newton's second law, is ma. So m is ma. So you can find your a equals to mg sin theta minus F divided by small m. Okay, all right.
Frictional force. The learning outcome is to explain the variation of frictional force with sliding force. Sliding force are also known as kinetic force. And we're going to define and use the coefficient of static and kinetic friction. Now, friction is a force between two surfaces that are sliding or trying to slide across each other. For example, when you try to push a book along the floor. Friction makes this difficult. The amount of friction depends on the material from which the two surfaces are made. The rougher the surface, the more friction it is produced. Friction always works in the direction opposite to the direction in which the object is moving, and friction always slows a moving object down.
Class, today we are going to look at frictional force. Okay, now what is a frictional forces? Frictional force is a force, okay, is a force that exists when two solid surface is in contact. Okay, frictional force is a force that exists when two solid surface in contact. Say for example, if I have a book on the surface of a table, then these two surface, which is the book and the table, are in contact, so therefore there will be an existence of a frictional force. Okay, now frictional force oppose relative motion. Number 3, oppose relative motion means if the direction of the motion is in this side, then the frictional force will oppose the relative motion. That means if this is an applied force, so the frictional force will be in the opposite direction. I'm going to symbolize friction force as Fr, yeah, but it's not resultant force, yeah. This Fr I'm just going to symbolize here just to explain to you all that it's a frictional force. Now frictional force we have two, okay, we have two. One is static friction, okay, static friction that exists when the object is at rest. static friction that exists when the object is at rest. Okay, it opposes the motion on a rest body. Okay, then we have kinetic friction, which is friction that exists when the object is in motion. Okay, where it opposes the relative motion of the object. Okay, so we have two types. One is static, one is kinetic. Okay, now let's look at this example here. Static friction is the friction between two solid surfaces before relative motion occurs. That means before relative motion occurs means at rest. When the body is at rest. Okay, alright. Now, static when the body is stationary, which is at rest. Static friction balance the applied force. Okay, static friction balance the applied force. That means force that you apply is balanced by the frictional force. Now, static friction is a self-adjusting force. Static friction is a self-adjusting force. Now, what does self-adjusting force means, class? That means, if in this example here, okay, I have drawn a figure here. Okay. Now, this object is stationary. Stationary means it has rest. Okay. Now, this is an applied force and this is a static friction force. Now, you want to move the body. Okay. So, the frictional force is exerted because it is against of the movement of the rest body. Okay. So, it's self-adjusting means that it is like if now FA is equals to Fs. Okay, FA is equals to Fs. Applied force is equals to static friction, because the word says static friction, F balances the applied force. Okay, so static friction balances the applied force. Now they are zero, they are zero. Okay, now in order to make the object to move, okay, the minimum applied force to give is, say for example, is 5 Newton. Okay, now you increase the force, you increase 1 Newton, so static friction will increase 1 Newton. You increase 2 Newton, then static friction will increase 2 Newton. But the object hasn't moved yet. You keep on increasing until then the static friction force also will increase until you come to the minimum applied force where the object will start to move. Then the static friction will also increases until 5 Newton. After 5 Newton object move, this is the minimum. After 5 Newton the object move from rest, then this 5 Newton of the static friction is called as limiting static friction. Limiting static friction. Okay, that's why they call this as self-adjusting force. Static friction is what? Self-adjusting force. It increases as the applied force increases until it comes to a value where if the applied force is greater than the value, then the object will start to move. Okay, so this is called as limiting static friction. Now, what is limiting static friction, class? Limiting static friction, okay, it's here, is the maximum static friction between the two surfaces. This occurs just before the surface slide over each other. That means before the object moves. Okay. Now, if the applied force is increased and yet the body does not move, then the static friction also increases. Okay. Why? Because it's a self-adjusting force. If you see here, first their FA equals to Fs. Alright. Then you increase the applied force, you increase the static friction force. You increase until you come to a maximum value of the static friction force, which is a minimum value of the applied force. Okay. Then what happens? After this, the object will start to move. minimum value is start to move, then this will be the maximum value of a static friction. It's called as limiting static friction. Now, the symbol for static friction will be Fs. So, limiting static friction Fs is equals to mu Sr. This is the formula how to find friction. Okay, so Fs is called as limiting static friction, is the maximum static friction. Okay, now mu s is called as coefficient of static friction. It's called as what? Coefficient of static friction. Okay, now because the coefficient of static friction depends, first thing, nature of the two surface. Nature of the two surface in contact. That means it depends on the nature of the two surface in contact. Either they are rough or they are smooth. It depends on that. Okay, nature. Nature means either rough, either smooth. That is called as nature. Okay, and the value of mu s is greater for rough surface, and usually the value of mu will be greater than 0 or equal to 0 and will be lesser or equal to 1. Okay, so this is the range. When we do the experiment, there's an experiment we have to do in form 6 where you have to find the range for the mu. Okay, so the minimum value of mu is 0 and the maximum value of mu is 1. So the value of mu is greater for rough surface. Okay, alright. What about static friction? Now let's look at kinetic friction. Okay, now kinetic friction is a friction that is two surface, friction between two surface that slide over each other is known as kinetic friction or sliding friction. Kinetic friction has another name which is also called as sliding friction. Okay, symbol will be F, K, mu, K, R. Okay, F, K, mu, K, R. Okay, now what is R? R is a normal force. Okay, R is what? R is a normal force. Now what is mu K? Mu K is called as coefficient of kinetic friction. Okay, now as static friction, it depends on the nature of the surface in contact, whether it's rough or it is smooth. Okay, now the book says the kinetic friction Fk is less than the limiting static friction. So the book says the value of Fk is less than the value of Fs. Now why is it? Because you see class, when you have an object which is on the surface, okay, it is easier. Now you push the object. For the first time when you push the object, you find it more difficult when it's at rest. But as the object is already moving and you are pushing, you find it is much more easier to push a moving object than to push an object that is at rest. Okay, so that is why kinetic friction is less than the limiting static friction Fs. Okay, now this number 7 and number 8 is just an example. Okay, so I'm going to show here. I'm going to redraw that back. This example here, figure 3.7. Okay, now I'm just going to explain here. Now we have an example here. This number 7 and number 8 is just an example here. Okay, now what we do is that we have a block. Okay, a block on the plane and slowly tilting one end of the plane until the block just start to slide down. So the existence of the friction is the limiting static friction. Just start to slide down. That means it is from the rest. Okay, alright. So what we do this is, let me just draw better. This is just an example, yeah. Okay, now I have a block in an inclined plane. Okay, now what's the first thing we do, class? Okay, what's the first thing we do? All right, we draw the forces. Okay, we draw the forces. Okay, let me get a red pen. Okay, we draw the forces. The first force that acts on this is mg, which is like this, correct? Okay, mg. Then we resolve. This will be, this is theta, this is theta, this one will be mg cos theta, this one will be mg sin theta. Okay, then we have another force here. Okay, from the surface to the surface we have a normal force, okay, which is r. Okay, and then the question says, the thing says just start to slide down. That means it was at rest, and then they incline, they tilt it until it start to slide down. So it's from the rest. So we have fs. Okay, all right. So now we solve this. Okay, if the block goes this way, all right, so the motion of the block will be in this motion here. Okay, so from here, if they are balanced, okay, they are balanced, we can say fs is equals to mg sine theta. Okay, r is equals to mg cos theta. Okay, all right, so what is fs? Fs is mu s r equals to mg sine theta. Then from here, r equals to mg cos theta, so I put mu s mg cos theta equals to mg sine theta. Okay, so mu s is equals to tangent theta. That's what, how to find the coefficient of static friction. So that's what number 7 and number 8 is trying to say. Mu s is equals to tangent theta. It's just an example. Okay, they just use an example here. Okay, now number 11, it says, number 11, it says what? The coefficient of kinetic friction UK is determined in the same manner as the determination of US, except that the block is given a slight push each time the angle is tilt increased. Okay, so for this number 11 is explained about this. It is given a slight push. That means there's a relative motion. Okay, so the friction is a kinetic friction, and how you determine mu k? You determine the mu k in the same manner. Mu k equals to tangent theta. No need to memorize this formula, okay? No need to memorize. This is just an example. This figure will change, okay? Now let's do example 3.12 together. All right. A 12 kg block. We have what? A 12 kg block. On a horizontal surface with a horizontal force applied. So this F is an applied force. Okay, is shown in the figure below. The coefficient of friction between the block and the surface is 0.85. Okay, mu is 0.85. Okay, all right. Calculate the minimum value of F to slide the block. Minimum value of F to slide the block. Minimum value of F means they want us to calculate the minimum value of the applied force. Okay, so that's why they say calculate the minimum value of F to slide the block. So here the applied force is in this direction, correct? So if I redraw back, it's like this. Correct? Okay, so minimum value of F to slide the block will be FA is equals to Fs. So Fs is equals to what? Mu mg. So mu is 0.85, m is 12, and g is how much? G is 9.81. Okay, now why did I put mg here? Okay, like this. This is the weight, W. This is the normal force, R. So we know that W is equals to R. Okay, and R is equals to mg. So I substitute Fs is mu R and R is mg. I substitute inside, I get my answer. So my answer will be 0.85 times 12 times 9.81. It will be 100. Okay, minimum value of F. Minimum value of F will be a maximum value of Fs. Okay, alright. Now, if F is 25 Newton, now they up the game. They said F is 25 Newton. Okay, what is the frictional force acting on the block? They ask you what is the frictional force acting on the block. Okay, now the minimum value to move this block will be 100 Newton. Now 25 Newton is given to move this. Will the block move? Definitely no. From the rest, it will not move. So what will be the static frictional force? As I say, it's a self-adjusting force, correct? It will increase as Fa increases, Fs also will increase. So the value will be 25 Newton. Okay, alright. Now, if F is 125 Newton, what is the initial acceleration of the block? Okay, applied force minimum will be 100, correct? Now, applied force is 125. So, definitely the object will move. Okay, definitely the object will move. Okay, I draw again. This is applied force minimum. This one is maximum static frictional force. Okay, then now if F is 125 Newton, Fa, will the object, what is the initial acceleration? Will the object move? Definitely the object will move. And the kinetic friction that acts on the object when it moves is called as kinetic friction. Okay, so F is 125 minus 100 equals to MA. 125 minus 100 is equals to MA. So 12A, this one will be 25. So 25 divided by 12 is 2.08. Okay, all right. Okay, that's it.
The frictional force is classified into static friction and kinetic friction. In static friction, the frictional force resists force that is applied to an object, and the object remains at rest until the force of static friction is overcome. In kinetic friction, the frictional force resists the motion of an object. For example, static friction can prevent a book from sliding down a sloped surface. The force of static friction keeps a stationary object at rest. Once the force of static friction is overcome, the force of kinetic friction is what slows down a moving object. Thus, we can say that on the basis that whether the force of friction is acting on the body at rest or in motion. Now, if you look here, static friction, the key word is it acts on a body that is resting. Kinetic friction, the key word is it acts on a body that is in relative motion. Static friction is the opposition of motion, opposition to the beginning of motion. And kinetic friction is opposition relative to motion of the body. That means it's the movement of the body.